So I'm Marco, and today I'm going to talk about how can we migrate from JavaScript to TypeScript. I'm not going to compare both of them, but I think using some strategies we can take the all advantages of using TypeScript, even not writing TypeScript, which is good. So let's first talk about TypeScript. So the motto is JavaScript that scales. I will start by just giving a brief introduction about TypeScript and how it works. So TypeScript is a superset of JavaScript that compiles to JavaScript. So basically we write TypeScript with all fancy features and types, and then it compiles to plain and human readable JavaScript. It includes all features from ECMAScript 6, 7, and much more like types, interfaces, union types, generics. So basically we have ECMAScript 5, ECMAScript 6, and then we have TypeScript. So how to TypeScript? So how can we start using TypeScript? So first we just install TypeScript as a normal dependency. We just install it as a dev dependency. We can also install it globally. If we have some kind of external dependencies, we just install them as also like a normal package. At this case, I'm installing the node declarations. So if you are in the node environment and you need to access like the node libraries and the node properties, you need to install these declarations. So then we create our TypeScript file. Then we compile it using the tsc command. So we can specify some arguments to the compiler. At this specific case, I'm just saying that I want to compile to ECMAScript 6. And then it generates our JavaScript file, and we can just run it as a normal JavaScript. So here is an example. I hope you can see it. So as you can see, we are using like interfaces, types, abstract classes, protected visibility, so lots of features that are not supported in JavaScript. So what do you think that's going to happen when we try to compile this code? Do you think that it will generate extra code to emulate the, for example, protected behavior? Well, the answer is no. It just compiles to plain and very human readable JavaScript. Sometimes it generates better JavaScript than some developers, which is good. And it does not generate any extra code that might have performance issues. So it generates very performant JavaScript and human readable, as you can see. So declaration files. What are declaration files? Basically, declaration files are files that describes a library written in JavaScript. It just describes the methods and properties because the behavior is already in the JavaScript library. So it provides Intellisense and module typification. That's why when we install a declaration file, we have the Intellisense and all the types of that library. So it gives us extra confidence when we are updating the library. So for example, imagine that we are using library A version 1 and we want to update to version 2. So usually what we need to do is go to the documentation, see the breaking changes, and try to find in our code where things are breaking. So having TypeScript and declarations, we can just install the new declarations, we compile our code, and it will automatically report all the errors in our code where things are breaking. So it gives us like really extra confidence updating libraries. Other thing is declarations are suffixed by d.js, so that's why some projects that are already embracing the TypeScript, you can find some d.js files from the declarations. And we just install it as a normal dependency, as a dev dependency. So here is an example. This is the Koa definitions. So basically, as you can see, in the response object, we have status, message, body. So there is only properties and methods here on the bottom. So there is no behavior because the behavior is already in the JavaScript library. That's why when we install the declarations and we try to access an object, we have the old Intellisense It's from this declaration file. Developer experience. So using TypeScript, it really gives us like a better developer experience. Types prevent bugs. So if you write this code and somehow you just are passing the wrong type to a function, or you just misspell writing a method, well, let's be honest. I think everyone have just misspelled writing a method or a property. So if we try to compile this, we get immediately feedback instead of just having feedback in runtime. So it can save us from some bugs if we don't have proper testing. So this is a fast way to prevent some issues. Refactor code. So refactoring code, it's much easier. Basically, we just rename a property and it will find all places where we are using that type, and it will change in all places where we are using that type, which is awesome if we are refactoring a huge application. Intellisense. So once again, since now we have declarations, we have this experience, which is really nice. And now that we know the basics about TypeScript, more or less, let's talk about migration. So how can we migrate our JavaScript applications from JavaScript to TypeScript? So let's define our goal. I have a simple web server written in JavaScript, and the goal is to migrate to TypeScript. So you can find the code here. Feel free to check out. So let's define a plan. First, we need to install TypeScript, as obvious. Then we need to install the declarations. In this specific example, since we are in the node environment, I need to install the node declarations and also the happy. I'm using happy as framework. Then we run the tsc -init. This command basically initializes TypeScript configuration file. So instead of passing all the compiler options via argument, we can specify the options inside this file. Then we need to enable this option, so allow.js. This tells to the TypeScript compiler. So instead of just looking at the TypeScript files, now you are also compiling the JavaScript. And optionally, we can also enable this option. So these options means you are trying to find some errors in the JavaScript, and I will explain how the TypeScript compiler will find errors in JavaScript. And then we just start renaming our JS to TS. We fix errors and until we just migrate the whole application. So let's stop talking and let's do a demo. Maybe I need to. Can you see it? I'll start by showing the package.json. So as you can see, I just have happy. So it's the JavaScript web framework library. It's already in the version 18, but still. And then as dev dependencies, I have TypeScript and node declarations and happy declarations. So, and then I just created a few scripts to help me compile the code. So no magic here. Now, as I mentioned before, I have initialized the compiler options file. And let's show the code. So basically this is like a web server. I will just run the server. Source index. So, well, it's just a dummy API that returns some. Let me make the screen bigger. Just return some tasks. So our server is running, it's working, it's written in JavaScript right now. So everyone is happy. So let's start migrating our application to TypeScript. I will just choose this file. It's where I'm just creating the server. So what I need to do is basically rename to TypeScript. And now instead of using this way to export, I'm using TypeScript way to export things. And let's try to compile this. And well, as you can see, it generated a folder here. It's like our destination folder. And as you can see, we just have the TypeScript file. So it's missing the whole project. So we also need to include the JavaScript files. So we go to our configuration file. And now we say that I want to enable this option. And I will try to compile it again. Okay. Now in the dist folder, we have the whole application. Cool. But okay, yeah, we just converted the file. Let's check if it's still working. Now I can run the npm start because it's pointing to the destination folder. Okay, it's running. Well, not a big deal. Let's make things interesting right now. So I want to, now that we are using TypeScript, I want to use TypeScript to analyze our JavaScript code. I'm going to just enable this option. And now the TypeScript compiler will also analyze our JavaScript. And it will try to find some errors. So it seems that we have 2 errors here. Well, the first one, it says that type number is not assignable to type boolean. So in this file, basically we are passing a number instead of a boolean. But how TypeScript knows this is an error? So basically TypeScript analyzes the JS doc. Here I define the JS doc. As a good JavaScript programmer, we should write comments and write JS docs. So here in my task, here is how we define types in JSDoc. I'm saying that my object task has a property then that is a boolean. And we were passing a number. So the TypeScript compiler analyzes the JSDoc and it's reporting an error. So now we can fix this. So we find an error in our JavaScript code. And it's still JavaScript. So let's fix the other problem. Argument of type string is not assignable of parameter number. So if we go to this folder, to the controller folder, it's complaining that we are passing a string and get method once again because of we have JSDocs. It's saying that it's expecting a number. But how TypeScript knows that params ID is a string? Because we have installed the happy declarations. So if we jump to the declarations, it says that params is a dictionary of strings. That's why when we access this property, it's saying that it's a string. So in here we can see the old definitions of the request object and all variables and types. And TypeScript basically knows how to read those files and report errors. So to fix this, we just need to convert this property to a number. Let's just trust that is a number. So let's run it again and, well, we don't have problems, which is great. So we fixed 2 issues in our JavaScript code. So if we didn't have proper testing, we couldn't find these errors easily. So, but let's make things even more interesting. Let's go to our tsconfig file, and it seems that we have some cool options here. So basically this is like strict type checking options, and here we can find like more rules to our TypeScript compiler. So for example, strict null checks, strict function types, and there is more. options. So by enabling these options, let's check if we can find more problems. Well, yes, we found more problems. So object is possibly undefined. This one is sketchy. It might have some trouble with this one. So how TypeScript knows this? Once again, here in the JS docs, it says that this method, it might return a task or undefined. So if it's undefined, we are accessing an object that it can be undefined, and we can have a problem in runtime, and our server could just stop running, and our customers would complain. So let's fix this, and let's check that task is not undefined. So, and as you can see, this is still JavaScript. So we can just like write TypeScript as we want, and if we write proper JS docs, and if we install declarations, we can still have the all benefits of the TypeScript compiler. So let's just, I don't know, refactor another one. Let's change this one. So as you can see here, I don't have any kind of Intellisense, but since now we are using TypeScript, I can just change this to error type. And now, when I access this object, I have all properties of the error type. So let's just print the message. So right now we have some kind of hybrid application. Some files are in JavaScript, some files are in TypeScript. I'm not going to change all files, but let's just test this. Well, let's make sure that I compile it. We don't have problems. I just compile it. Now, it's still working. So, because at the end, it just generates a plain JavaScript that knows how to interpret. So here you can see that the generated JavaScript is very human readable. And the JavaScript that was compiled, it's basically the compiler just copied the JavaScript, and for example, it forces to use strict, which is one good practice when we are using JavaScript. So there is like no magic behind. So this way we can easily smooth migrating our JavaScripts to TypeScript. So new features could use TypeScript, and we could like slowly migrate the old features to TypeScript. Or we can just stick with JavaScript, and our team is still using JavaScript. But if we install the TypeScript compiler, we can find some potential errors in our code, which I think it's good, and the effort is not big, I think. It's just installing the TypeScript and the declarations and run the TypeScript compiler. So let's just recap. So converting JavaScript files to TypeScript and enable the allow.js flag. So this flag says to the TypeScript compiler to also compile the JavaScript to our destination folder. Then optionally, if we want to take advantage of the TypeScript compiler and the JS docs and the declarations, we enable the check.js property, and this flag or option take advantage of the things that I've mentioned, and it tries to find some errors. And if we want to be even more picky, we can enable the strict type checking options, and it will find even more problems in our code. For example, the null strict problem that we had before. And basically that's it. So basically what happens if we are using a JavaScript library that does not have declaration files? There is no problem at all. We can just install that library, and we can use it in our TypeScript code, but we don't have types. We just use it as we do in JavaScript.
So you ignore the type.
Exactly.
Well, you don't go and write on your own the type.
Exactly.
Okay.
So it's treated as a JavaScript, because at the end TypeScript, it will compile to JavaScript, so everything is compatible with JavaScript. Well, what I recommend for those cases is if you know the library, you can contribute to the community, or you could just like isolate that library and create your own interfaces, and then the rest of your code will have types.
Thank you very much, my friend.